Here on question 9, we're asking to prove that y equals x squared minus x minus cosine x has a 0 on the interval 0 to pi. Recall that a 0 means the same thing as an x-intercept, or sometimes we call that a solution. There's a bunch of different, a bunch of different names. We might even say that a root, right? It has a root on that interval. Nonetheless, how am I going to prove that it has a 0 or an x-intercept? Well, recall that a 0 or an x-intercept means that the y value has to equal 0, correct? So if you want to have an x-intercept on a graph, draw a quick sketch. This would be an x-intercept because the feature is the function has a height of 0, right? The function has a y value that's equal 0. That would put you on the x-axis. So I need to somehow prove that this function can have a y value that's equal to 0. Now, I'm not going to go and start plugging in random points and try and prove that, right? That wouldn't make sense because I have no idea what x value would actually satisfy that. But instead, what I'm going to do is I'm going to try and use the endpoints. And I'm going to say, well, if the endpoints somehow show that the graph would go above the axis to, let's say, below the axis, or vice versa, right? It goes from below to above, then I would know somewhere in between the region, I have to cross the x-axis, right? I have to cross a height of 0, y equals 0, to get there, okay? This is the fundamental logic of the intermediate value theorem, right? So this problem is asking me to use the IVT, right? So let's try and use the IVT. Note that the IVT requires us to have a continuous function, right? This was one of the conditions to be able to apply the IVT. If your function is not continuous, you are not allowed to use this theorem, right? So first things first, I'm going to go ahead and see and state whether this is continuous. So x squared minus x minus cosine of x. X squared minus x is a polynomial, right? So that's for sure continuous. Cosine is a trig function where everywhere in its domain, it's also continuous, right? You think about the cosine graph, it's a sinusoid that goes up and down over and over for all x values. So the combination of these two together are going to be continuous, right? So I could say y equals this is continuous on, I only need to state the interval, right? So I need continuous on the interval, although this is continuous for other values as well, right? It's continuous for any x you plug in here. So this is good. Now note, this is not actually a polynomial, right? So the full thing is not a polynomial. The fact that we have a cosine here means that that's not a polynomial, right? Polynomials have to be essentially terms like this, x to a power and a combination of those, right? Where technically the powers should be integer values, but nonetheless, this makes it not a polynomial, but it's still an expression that's a combination of a polynomial and a trig function. Both we know are continuous, okay? So this is good. Now that I know it's continuous, I can start to use the intermediate value theorem. So then I can say using the intermediate value theorem, and remember the wording here you might have is slightly a bit different than mine, but nonetheless, right, we're going to try and use the intermediate value theorem knowing that my function already was continuous. I now need to show that the height I'm looking for is between the other two heights that I get from plugging in the two endpoints, correct? So I'm going to try and prove, let's do y of 0. Well, what happens when you plug in 0? 0 squared is 0, minus 0 is 0, minus cosine of 0. Remember, cosine of 0 is 1 from the unit circle. So this means it's 0 minus 0 minus 1. So my height there is minus 1. This needs to bound my value at some point, right? So I'm looking for some value c, some x value c in between 0 and pi that gives me an output that's hopefully 0. And that's going to be bounded by the other height, right, at pi. So we get y at pi. What happens when you plug in pi? Well, you get pi squared minus pi, and then minus cosine pi. Cosine pi is -1, so you're getting minus negative 1, which is just plus 1, right? Two negatives turn to a positive. Now, note that pi squared minus pi would still be a positive number because pi squared is much larger, right? Think about it. Roughly 3 squared is 9. 9 minus 3 would be roughly 6, if I'm assuming that these are obviously bigger than 3, but I'm saying they're 3 for simplicity. And then plus 1 would still be a positive number, right? So we're getting a number that's slightly bigger than 7 in this whole kind of mess here, roughly. Therefore, negative 1 is certainly bounding 0, and 7-ish is also bounding 0, right? So this inequality, as we currently have it, is true for some c value that's bounded between 0 and pi, right? So if the y values are bounding this expression, that only exists when the x values are also bounded, right? Therefore, so we finish this off, we say, okay, therefore, our value, y, and we can say y of c, right? So y at that point, or y, must equal 0 at least once, right? At least once, presumably at x equals c, for c being bounded between 0 and pi. And then you can say y, right? So I could say like according to the intermediate value theorem. I'm going to put IVT here just to kind of abbreviate so we have some space. But remember, we want to write this out if we're on the exam. You want to put the full word, right? We want to write IVT. We don't. We want to write intermediate value theorem. We don't want to just say IVT. Okay. But that would be it, right? So if you got to prove something, if you have to prove that a y height exists, we want to use the intermediate value theorem to prove that, right? That's really the only theorem we've looked at to be able to guarantee whether a height occurs or not, okay? And don't forget the big condition of continuity, right? If you are not continuous, you cannot use this theorem, all right? So there you go, question 9.